It's time for some more definition. That's death by definitions, by the way. Have a lot more, just like we did a couple of videos ago. Some of these you've probably heard about. Let's talk about how they interact with math. We're going to start talking a little bit about economics. I'm not an economist, just general mathematical knowledge of economics. And that's all you need as well. So in economics, there's a model for how prices are determined in a free market. That's important. That relates supply, demand, and price. All three of these things are related. So when we talk about supply in this class, we'll say how many units, maybe we'll call that Q sub S or QS, a supplier is willing to produce at any price P. Okay, so P is the price, Q sub S is the quantity that that supplier is willing to produce. So if the price of that item, the price of selling that item or buying that item, at that price, and I should really specify that, any sell, it's not the price that the supplier has to pay to produce it, it's the price for the seller or the supplier to sell at. So if we can sell at higher prices, will suppliers increase or decrease how much they're creating? Well, if we're selling at higher prices, the supplier is probably going to want to sell more items. So supply is going to go up. Whereas demand is how many units, we'll call that Q for quantity, and then D for demand, the consumers are willing to buy at any price P. So it's the same P. I'm not going to write that though. So again, if the price of buying the item goes up, are people going to want it more or are people going to want it less? Well, probably fewer people are going to buy it if it's more expensive. So these are functions. And the input or output is not necessarily clear. We can have the input be the price and the output be supply and demand. Or we could have the input be supply and find out what price as an output we need to get that supply. So it's not, we can do it either way, usually. And these are functions in either case, usually. So we have two functions, supply and demand. They both depend on P. Where those functions intersect, the price point where supply is equal to demand is the equilibrium price. Again, where demand equals supply, that's the equilibrium price P star. It's also known as the market price. And it's of the market price is producing Q star units. So we have the star, the asterisk as a exponent. Superscript is the word I'm looking for when we're at that equilibrium price. And we're going to talk about linear functions here, but in reality, this could be any kind of function. Supply and demand functions can get pretty gnarly depending on how good of a model we want. We can model these real life situations with lines, but you're going to get a more accurate model with more complicated functions. We're just doing lines right now. So let's use this. At a price of $2.50 per gallon, those were the days, there is a demand in a certain town for 42,500 gallons of gas and a supply of 20,000 gallons. Okay. So we have one price. Here's the demand. Maybe this is our QD. And here's our supply. Maybe this is QS. Oh, now we have a new price because at a price of $3.50, I'll call that our first price. This is our first demand, our first supply. So now we have another price. I can call that P2. We have a new demand, QD2, of that much, and a new supply, QS. That's not an S, Jason. You should know that by now. A new supply. So we're going to assume that supply and demand are linear. We're going to find the equilibrium price and quantity. Well, if we need to find the equilibrium price and quantity, we need to know what those are. Equilibrium price is where these functions intersect. Oh, okay. So that's going to be where the demand is equal to the supply. And that'll let us find the P and the Q. The P star, equilibrium price, and the demand at that one, we'll call that Q star. A lot of variables here. A lot of things that we're looking at. So just like before, when we found break-even points for cost and revenue and profit, we said, okay, well, the break-even point is when revenue is the same as cost. That means to find that, we need revenue and cost. Here, it's the same idea. The equilibrium price is where supply is equal to demand. We need to find these functions. Find these functions. So let's look at demand. What's demand going to look like? Assume supply and demand are linear. So we know demand's going to look linear. It's going to be some B value plus some slope times the input. What's our input here? Let's say, right, our input is going to be the thing that affects demand. What's affecting demand? Price. And let's say that's in dollars per gallon. So here's what our demand function is going to look like. It's a linear function. The output is QD, input is P. Instead of y equals b plus mx, it'll be QD equals b plus mp. Because we don't have y's and x's anymore. And a lot of times in this class, we won't be dealing with y's and x's. All right, so what's the starting value? What's the slope? No clue. Okay, but notice what we have. We have a price and a demand, and we have another price and another demand. We've got 2 points. We can find a line from 2 points using topics that we've talked about in this class. Great. I did not give enough white space for this question. Sometimes I guess, and this is half the reason I give you all Word documents. So if you want to add a little space sometimes, if you say, Jason, you never give enough space, you can add it before printing it out. Okay, so we need to find these things. We'll find the slope first. Slope for demand. And if you really want to be precise, you can use a subscript, because we're also going to eventually need to find the slope for supply. We can't use M for both of them because they're going to have different slopes. Slope for demand is going to be the output for our second demand minus the output for our first demand minus the price, the input for our second, minus the input for our first one. These are already labeled for us. Right? QD2 was 25,500 of gallons. That's 25.5 minus QD1. We said that was 42.5. Second price was $3.50, and the first price was $2.50. Subtract that out, and we get, I believe, negative 17 over 1, or negative 17. Negative numbers. Negative numbers can be a problem sometime in applications. Does a negative number make sense here? Negative means decreasing when we have a slope. Our slope is decreasing. That says an increase of price is going to decrease our demand. Typically, when price goes up, demand does go down. Usually, the slopes of our demand functions will be negative. Okay, so that sounds all right. So our demand function is B, which we still don't know, plus M, which is negative 17, times our price. There's nowhere near enough space for this. I'm so sorry. I usually don't give the white space this level of wrong. Now we need to find B. Okay. Oh man, what am I gonna do? What are you gonna do? I don't know. Let's just do something. Let's find the starting value. So once we find the slope, if we have 2 points, we can find the slope from those 2 points. And then we find the b value, the starting value, by using either one of those 2 points. Right? We know that P of $2.50 leads to a demand of 42.5. We can plug in both of these values to find what B has to be. So QD is 42.5, and that's going to equal B minus 17 times P, which we said was 2.5. We can solve for our B value. 42.5 is B minus 2.5 times, that's 34 plus 8.5. I'm just going to use a calculator. 17 times 2.5. We're subtracting 42.5. Oh, what a coincidence. Now let's add 42.5 to both sides. You're going to get that our B value is 42.5 plus 42.5, which is going to be 85. So we finally have our demand. All right, I'm just going to make a note to myself to give you all more white space before I publish these notes. Add more white space. To example 5. So y'all shouldn't have this issue. You can just laugh at me, struggling in pain. So our demand is B, which was 85,000 gallons of gas, minus 17 times P. We are a third of the way down the problem. We have to find demand. We have to find supply. We have to find when they're equal. So let's take a moment, let's pause and talk about this while I fix what I'm going to do next. So what does this equation represent? This represents the relationship between demand and price. Okay? So as the price that the sellers can sell at increases, the demand is going to go down, right? People are going to want to buy fewer of these things. Okay? And specifically, this says that if gas were free, if the price was 0, if gas were free, the demand would be for 85,000 gallons. Again, it's not really true. If gas were free, people would be taking an insane amount. But it's just a model. It doesn't describe reality perfectly. These are linear functions, very simple functions. It's just a model. And then similarly, this says that for every increase of price of $1, the slope is negative 17. So as the price goes up by $1, demand's going to go down by 17 thousands of gallons of gas. Okay? That's how we can interpret that equation. All right, now I'm ready. So let's continue on your paper, but my other program. So let's find the supply. So we also know that supply is also going to be linear, right? Supply is linear, like so. So when we find our supply, that's also going to be some starting value. Again, I didn't put a subscript before. Technically, this should be the starting value for supply, plus the slope for supply, times the price. And we can use the same P. And just like before, we're going to look at some ordered pairs. Over here, we said the first price was $2.50. We said the supply for that was 20,000 gallons. That first QS right here. And then at another price of $3.50, we had another supply of 28,000 gallons. Again, if the price is increasing from $2 to $2.50 to $3.50, the supply will increase as well. If the price that things sell by goes up, there's going to be more supply to an extent. Can't make oil out of nothing, but they will be more willing to sell it. So we're going to use these points again to find the second equation. This is a really good point. It's essentially doing the exact same thing that we did for the demand, But for the supply, pause the video, do this part on your own using the demand function as a model. So if we do that, we can find the slope. That's going to be, again, the difference in output, second minus first, divided by the difference in input, second minus the first. You saw earlier that we also use this formula, right? Change in y over change in x, change in output over change in input. That's another way of thinking about slope. We have a lot of different equations that work here. The numerator will be 8, the denominator will be 1. We'll get that our slope is 8, a positive slope. As price increases, supply should go up because we have a positive slope. QS is going to be that B value, which we still don't know, plus our slope times the price. Every increase in $1 is going to make our supply go up by 8,000 gallons of gas. And now you can choose either one of these points to find our B value. I'll use the first point. I'm going to use the first point of this because they're smaller numbers. So Q sub S is 20, replace it with 20. BS, we don't know that. Well, you might know some BS, but you don't know this BS. Okay? Anyway, I hope you're at least groaning from that. And the price is $2.50. And now we simplify. 20 is B sub S. 8 times 250 should be 20, I believe. Subtract 20 from both sides. We're going to get that BS is 0. There's no BS here. Ha, ha, ha. And again, 0 makes us a little uncomfortable, just like negatives sometimes make a little uncomfortable. So let's write our equation and see if it makes sense. So BS is 0, so we just get 8 times P. The supply is just going to be 8,000 gallons times the price. First off, does that make sense with our points? If the price is $2.50, what's 2.5 of 8? 24. Well, no, 20. Good. 20 is what the price was. What's 3.5 times 8? That's going to be 24 plus 4, 28. Good. So this does match with both of our points for our supply. So we can go over here and say our supply is just going to be 8 times that price. So all we need to do to finish this is find when QS equals QD, right? That's the equilibrium price is where that happens. So we're going to say, when is QS equal to QD? Well, QS, we said, was 8 times P. And QD, we said, was 85 minus 17P. We need to find when these are the same. We're going to add 17P to both sides. Cancels on one side. The other side becomes 25P. And now we need to divide both sides by 25 to get what price needs to be. 85 over 25, that is 17 over 5, I think, which is 3.4 maybe. Let's check this. Whoa. 85 over 25. 3.4. Nailed it. So that's going to be, sorry, I have to get on the right scene. This is our P star. It's the P value when these things are equal. Equilibrium price is $3.40 a gallon. Equilibrium price is $3.40 per gallon. What's the equilibrium quantity? I don't know. This is the quantity when supply equals demand. I don't think I specified that. Q star is the quantity where demand equals supply. So what's our quantity? Well, we could use QS or we could use QD. They're equal. We could use either one of these quantities to answer that. Just use one of them. The supply formula is easier for me. So I'm going to say that the supply is going to be 8 times P star, 3.4. And 8 times 3.4 is some number. A demand of 27.2 thousands of gallons of gas. Gotta get to the... Did I say 27.2? I've got too many windows open now. 27.2. Again, that's thousands of gallons of gas. And we use that for our equilibrium point. Okay, so the equilibrium price, $3.40 per gallon. And quantity is 27.2 thousands of gallons of gas. And that totally fit in the white space that I gave you. Well, hopefully it did fit in the white space I gave you. It didn't fit in the white space I gave me. That's how it all ties together. Again, there's a lot going on in these sections. You can break it down into those individual steps from the first video. You can model your questions after these questions. I'm trying to take my time and not go too fast, but these are very long problems. The next video, we just got another example for you to hopefully get more practice. Let me know if you have questions. Hope you're enjoying yourself. Hope you're more awake than October is, but maybe, I don't know, maybe y'all are really identifying with October right now. Anyway, have a good rest of your day, week, life. Bye-bye.